You know, for years, we've all been treating software delivery like it's some kind of complicated puzzle we just need to solve. But what if we've been looking at it completely wrong? Today, we're diving into a really radical new perspective. We're going to combine two groundbreaking pieces of research that might just flip everything you think you know about building complex systems on its head.
Okay, so this is the question, right? It's on everyone's mind in tech. We've got these incredibly powerful AI co-pilots, these new AI agents, and it feels like we're right on the edge of a massive revolution. But is it really that simple? Can we just, plug in an AI and watch all our delivery headaches just vanish? Well, the latest research gives us a surprising and, frankly, a much more interesting answer.
And here we have it, straight from Google's world-famous Dora research. The key thing to get here is that AI isn't some magic wand. It's a massive amplifier. Think of it like a giant microphone. If your delivery system is strong and clear, AI will make it broadcast louder. But if it's tangled and chaotic, well, AI is just going to amplify all that noise. And that one idea, right there, it sets the stage for everything else we're going to talk about.
So let's jump into part one, the established wisdom. This is what the experts over at Google have found after studying literally thousands of organizations. It's the current consensus on how to get your teams ready for this new AI-driven world.
So what's really fascinating when you look at these findings is just how clear the pattern is. Dora found that AI completely supercharges teams that already have their act together. So, what do those high-performing teams all have in common? Well, for one, they invest heavily in what are called internal developer platforms, or IDPs, to standardize how they work. And two, they are absolutely obsessed with the developer experience, what we call DevX, to make life as easy and frictionless as possible for their engineers.
So, the big takeaway from the Dora report is pretty straightforward. Before you can tap into those huge benefits from AI, you have to build a really solid foundation first. You need a platform that makes doing the right thing the easy thing. This is basically the industry's thesis. But what if that's only half the story? Okay, hang on, because this is where things get really interesting. A brand new research paper just came out that suggests our biggest problems, they're not about platforms or tools at all. No, they're about something much, much more fundamental. They're about physics.
This quote right here from McIntyre's paper is an absolute bombshell. What he's arguing is that the dysfunction we see in our companies, the analysis paralysis, the endless meetings, the turf wars, it's not actually a human flaw. It's a property of complex systems. And that phrase, substrate independent, that means it doesn't matter if the agents are humans or AIs. The physics of the system itself will cause the exact same failures every single time. Now, to really get a grip on this new physics, there are two key ideas we need to understand. First up, we've got Goodhart's law. It's a really profound concept. The second you start grading a team on a specific number, they will figure out how to make that number go up, often at the expense of the real goal you actually cared about. And this is the perfect example. We've all seen this. You tell a team their target is to close more tickets. Guess what they do? They close tickets. The fast ones, the easy ones, maybe even duplicates. But are they solving the customer's actual problem? Not always. They're just gaming the metric because that's what the system is rewarding. It's not malice, it's physics. Okay, the second law is something called the data processing inequality. Now, I know it sounds really complicated, but the idea is actually super simple. Once information is lost, it is gone forever. You can't get it back just by staring at the summary harder. Just think about all the status reports you've seen. You have a complex project full of nuance and risks and dependencies, and it gets compressed down into a single green bullet point on a slide. All that nuance, all those early warnings, poof, they're gone. Adding 3 more layers of management to review that green status can't magically recover the information that was already deleted. The signal is lost for good. All right, so we've got this theory that coordination itself is what creates dysfunction. But what happens when you actually put that to the test? This brings us to the core of McIntyre's research, a controlled experiment where different teams of AI agents were all given the exact same task, build the same piece of software. And the results? They are nothing short of stunning. I mean, just look at this table. It shows a perfect inverse correlation. The simplest possible architecture, a single AI agent working completely alone, scored a flawless 28 out of 28. Perfect score. But the instant you start adding coordination complexity, like a hierarchy or a group of agents working at the same time or a gated pipeline that looks like a typical company, the performance just completely tanks, all the way down to a catastrophic 0. Let's just look at that visually for a second, because the drop-off is just so dramatic. You've got a perfect score from the single agent, and then it just falls off a cliff.
The org swarm, which was the system designed with all the typical checks and balances you'd find in a human organization, failed completely. It actually spent its budget on planning and review and didn't write a single line of working code.
But here's the crucial bit. They didn't just fail. They failed in ways that are eerily familiar to anybody who's worked in a big company. The org swarm got stuck in analysis paralysis because it was perfectly gaming the planning process. The hierarchical system saw its AI manager rationally defect. It decided it was faster to just do all the work itself instead of delegating, which is a classic micromanager failure.
The emergence system suffered from constant interface mismatch. Everywhere two AI-built parts were supposed to connect, they were totally incompatible. It's basically the AI version of two teams building to different specs. And meanwhile, what about the single agent? No meetings, no handoffs, no coordination. It just did the work perfectly.
And here it is. This is the absolute killer finding from the whole paper. McIntyre actually programmed the AI swarms with explicit rules to prevent these bad behaviors. The prompts literally said things like, "Do not get stuck in review," and "escalate disagreements quickly." And yet, the system produced the exact pathologies it was designed to avoid. The physics of the architecture completely overwhelmed the instructions.
So, it feels like we have a contradiction, right? On one hand, Dora is telling us, build better platforms for your people. On the other, McIntyre is saying, coordination itself is the problem, even for AI. So how do we square this circle? Well, this is the synthesis, and this is where we realize these two ideas aren't in conflict at all. In fact, they are pointing to the exact same solution.
Take a look. On the left, you have Dora's solution for humans, a great developer platform that cuts down on the need for people to coordinate through meetings and tickets, giving them clear, automated ways to get work done. Now look at the right, McIntyre's solution for AIs. Replace subjective code reviews and meetings with automated contract-based tests. They are the exact same idea, just applied to different substrates, humans and AIs.
And this just makes it crystal clear. Both Dora's platform engineering and McIntyre's contract-first design are really just strategies to solve the same underlying physics problem. It's all about minimizing that high-friction, subjective coordination and replacing it with clean interfaces and automated mechanical checks. For you and your team, this means every single meeting you can replace with a simple API call is a massive win against physics.
So, after going through all of this, what's the one thing you really need to walk away with? If you remember nothing else from this explainer, please let it be this one core idea.
We need a new mental model for how we approach our work. Let's call it the single-agent ceiling. McIntyre's research basically proves that the theoretical maximum performance always belongs to a single agent with zero coordination overhead. A single developer or a single AI working against a clean, self-service platform is going to outperform a complex web of committees and handoffs every single time. Your job, as a leader or an engineer, is to make that single agent as powerful as it can possibly be.
And that leaves us with one final provocative question. As you look at the challenges on your next project, the delays, the bugs, the frustrating meetings, ask yourself this. Are you trying to solve a coding problem? Or are you, without even realizing it, fighting a much deeper battle against the fundamental physics of coordination? The answer? Well, it just might change everything.